Hello everyone, welcome back. It has been a while since I last uploaded a video. I think 10 months ago I uploaded my last video. Due to my workload, ongoing engineering projects, I could not spend as much time here as I wanted. But I am really happy to be back and continue this series. Even now, I am very busy. I am in Egypt for one project, but I will continue to take a video for this channel. As you remember from previous video, this is our model. But if you did not watch my previous videos, please watch my previous video. Then you can come back to this video. We already modeled columns, beams, and defined the structural systems and defined the load pattern like this. I want to show just firstly like this. All of them we created previous videos and define load combinations accordingly Eurocode, accordingly LRFT, not Eurocode, LRFT. I can show like this, and we gave some dead loads, some live loads. Step by step, we gave all of them in SAP2000. Please check to the other videos because that groundwork is very important because everything we do from now on is built on top of that model. In this video, we will moving forward and focusing on wind loads according to Eurocode. And I want to show the name EN1991, okay, 1.4. We will use this for wind loads, okay? Please upload these PDF documents in internet. You can find in everywhere. We will explain the logic behind of the coefficients and how the loads are distributed and how to apply them correctly in SAP 2000 and based on real engineering practice, not just in a theory. If you are working with SAP 2000 and want to understand not only what to enter, but also what you are entering it, this video will help you a lot. Okay, for now, let's get started. First, I want to start with most important part of load calculation is I want to try to find this is the QPZ. Okay, we want to find this QPZ. Okay, what's the QPZ? QPZ is the peak velocity pressure. Peak velocity pressure at height Z. You can say H something. In simple terms, it represents the actual wind pressure acting on structure at specific height. We should determine, firstly, in our workflow, we should determine the QPZ and apply pressure coefficient and transfer the resulting load to the structural element. This is, I can say simply, I am repeating. First, determine QPZ and apply pressure coefficient and transfer the resulting load to the structural element. That is why QPZ is very important. Okay? And there are a lot of formulas here, but honestly, there is no real benefit in memorizing these formulas. What really matters is understanding what QPZ represents, why we need it, and how it is used in wind load calculations. And once QPZ is defined, the rest of the process becomes very straightforward. We simply multiply QPZ by the relevant pressure coefficient and then transfer the resulting loads to the element. So for these formulas, you can find a lot of Excel sheet is ready like this. Ready Excel sheet. You can find the ready Excel sheet. Is already somebody do, or from these calculations you can obtain yourself and you can create your own Excel list. But you should have this list, okay? This list. Maybe right now I am showing you to this relevant page, okay? You can find in Eurocode here relevant pages, and these are the relevant pages from the Eurocode 1.4. On the, you can check on the screen, and if you interest to this, I can explain this formula step by step in separate video because it will take time. But for this video, the key point is understanding the QPZ. We should obtain the QPZ. Okay? But don't tell me you are not explaining QPZ because I should explain in separate video for this QPZ. But for this video subject is after QPZ, okay? But you will find already QPZ here in Excel sheet, okay? From what I have seen on YouTube video, there are quite a few videos about the wind calculations, but most of them, not most of them, all of them, what I see is flat roofs, but single slope roof are usually not explained in detail. So that is why our example actually very good one. It allows us to see how to wind loads behave in a single slope roof. Okay, now let's get started here. On this page you can see on the screen, you will notice the H value here and such as 2H value. Before we jump into any calculation, first thing that we need to do, analyze which of these parameters actually applied in our cases. Eurocode provides different expressions and limits depending on the geometry of building. Okay, you should check this. And firstly, we should obtain, where is our by the way, I want to explain. You can see our building is single roof, single slope roof building, but I will give all of the wind pressure separately. You can see this small building and this is big building. So I want to start from big building, okay, and let's check from here, and we say WX I will give from here, and then if I give from here, our D is this, okay. If I give from here, our D is this. So you should understand this point if you are giving from WX from this, because I also watching some wind load videos, but they are not explaining. So if you are checking from here, D is here. If you are checking from here, D is here. So where I will start? I will apply WX from here, okay? So for this building, our D is this. And what is the height? D is this. D is this. and B is 3.5. H is view, measure, line. You can check to 20 meter. We can say to 20 meter. Okay. So let's turn to our page. What it is telling? Whichever is smaller. B is 3.5 and 2H is 40 meter, and whichever is smaller. So 3.5 is smaller. Our B is 3.5 and our D is B equal E 3.5 and D is here, view, line, 7 meters, 6.95 meter. Okay, D is this. So D bigger than E. So our situation is this. Firstly, you should solve here in your building. Whichever your building, you should solve. If you don't understand, take it back and recheck the video. So firstly, our one table is this, not table. Our one situation is this, and second, now as a second step, let's take a closer look at this table 7.1. Okay, in Eurocode 1991. Okay, first you can see in facade is divided A, B, C, D, E like this. You saw here already, is it? This is the side. And D, E is D and E. This is the WX, wind X side. Okay. And each zone represents different behavior depending on wind direction and the location on the building. Before choosing any values, we need to look at the H and D ratio. You know, you see that the coefficient are depends on H divided D. We know from H, we know D also. What was our D? When we were looking from here, our D was here. Is it view, line, and 6, 9, 50. Okay. And our H, 8. It means 8 is, we will choose the bigger one. Okay. 20,045. I will open the calculator. Divided by 6, 9, 54. So what we obtained 2.88. Okay, we just close this. And now what we will do? First, determine HT ratio for the building. Then select correct row and select correct zone A, B, C, D, E from here. If you are applying here, D, D, E, E. And if you are applying from side A, B, C. Okay. What we find our HT ratio is 288, and you will say to me, we don't find this ratio in here. But if you can see all of the pressure coefficient values is 1, 2, even here 1, 4, 0.1.1, 0.5, and 0.81, and it's changing here. You can see, and it's changing here also. D value is changing here, but with my value 2.88, just here should be changed. Okay, just keep in your mind. Taking video, small calculation for us. No, where is this? Small calculation. So you know this HD value 1 and HD value 5. This is for what I said to you. It is changing. Sorry, it is changing. It is changing just here. So I should calculate for E. For E. So yes. So what we will do, we will make an interpolation. Interpolation, you can see HD value 1, 5, and our value is, so I arranged it. Our HD value 1 and 5, and in here 0.5, 0.7. Our HD is 2.88. First step is define the interpolation range. Range is 5 minus 1 is equal 4. And distance for value from the lower limit. Lower limit, okay, 1, okay, 1, and our HD ratio is 288. So our lower limit is 188. Ratio within range. This is our range, interpolation range, and if I divide it by for this 0.47, that means in our buildings 47% of the way from HD to HD1 ratio and HD5 ratio. Difference between the pressure coefficient is 0.2, minus 0.2, and if we apply the ratio to coefficient, we will reach this value, 0.049. So at the end of the day, if we at the lower limit value 0.5 minus 0.094, we will reach 0.55. Okay, just we are making an interpolation. Okay, so you obtain this value. Other value is the coefficient are equal. You can see even here you can see is equal is changing here. If for example it is less than 1, it is changing here. Just keep in your mind, don't miss here. So we know our coefficient value anymore. Okay, we apply our loadings. Now we will continue with our Excel sheets. Okay, what I said in the beginning of our video, I said we will use this Excel sheet, but in this Excel sheet, first we will enter the basic wind velocity, this basic wind velocity, and in our case VB is taken from national annex. You should use the national annex. I am checking in SkySew also. Our project was in Kastolovice, and I checked the wind speed 22.5, but I will write 25. Okay, you can check wind load calculation here also, and you can check in internet, and when you make it Google, you can find this data everywhere. Okay, you can find, and then what I will write here 25. Okay, and Then we select the terrain category. It is Turkish, but this means terrain category. We can choose this because terrain affect the wind profile and turbulence. For our project, we are using terrain category 2. Okay. So, and once we selected that, sheet automatically fills in the corresponding parameter like as Z0 and minimum height limits. So after one, there are a few coefficients that are often standard or recommended values in Eurocode. We are not doing for nothing for this. So turbulence factor is often taken as recommended value 1. Orography factor is 1 if there are no special topographic effects. We can take 1. And this exposure factor is CE. I write this. How I find, I will show you. This is the table 4.2. Table 4.2 here is not so good, but you can find here because it is not obvious somewhere. Okay, I will I will show you from here. Our height was 20 meter, as you know. So 20 something like this. So our this is 0, this is 1, this is 2. I will put it here, and like this you can see the intersection of here is coming 2.93, 2.8, and I write here 2.8. So at the end of the day, I obtained 111 kilogram meter square. Okay. So now it is time to apply this wind load in SAP2000. In our example, where we look from here, okay, and I will apply from here. In our example, the tributary width is, I think it was 3.5. Yes, 3.5. Let's check again. Yes, 3.5, and we have a long 2 column. Sometimes my English is mixing with Turkish, so sorry about this. And so we have a 2 column carrying this load. We will distribute the wind load equally to these 2 columns. That means each column will take half of tributary width, 1.75 and 1.75. Okay, so what I will do, and I write 111 kilogram meter square. Let's change this close. This change, maybe I can write this, okay, directly. Okay, kilogram force and meter, and I can write like this. It will be correct like this. Otherwise you can turn also. And now assign frame load, distributed load. Again I choose WX, gravity Z, and 111. Okay, what was the no. Yes, I will go for that site. Sorry about this. Firstly, for D, it was D, is it? So I am looking for here and D. This is D. You can check. This is D. This is D. Sorry, and I am looking for here kilogram force and meter, and okay, everything is okay, and be careful. And D, for D is speed 10 is 0.8 already. Okay, multiply 0.8, sorry, 8 already. Yes, 8 to 8, and I will apply to do this. Apply. Yes, it's here. I will choose this because same application will be here. And as you know, it is equal 1.75, 1.7, sorry. And 1.75. Sorry, I made a mistake. 1.75. Yes. Okay. What I did, I will replace this. Okay, I will tell assign again framework distributed load, replace. Okay, and then for other I will choose the column and assign frame loads distributed same. So like this I applied my force. Yes guys, you can see our loads. I tried to explain the wind load application step by step without skipping any parts of process. But maybe I forgot, you can write in comment. The same logic and same approach will apply for WY direction and for negative pressure areas also. If you would like to go through these steps together with me, please feel free, leave comment below or contact me directly. LinkedIn, I have a LinkedIn and I have an email. Please don't forget to like video and leave a comment. It really helps the channel and lets me know which topics you want to see next. In upcoming video, you can be sure it will be very useful videos. I will continue building on same example. I will continue with this example as a base model, but however, to keep the things moving and avoid slowing down too much, I will also introduce other example such as how to create project plan using Primavera. In one example I will show Primavera planning. So make sure stay tuned